In this video, we'll go over questions in week 2 practice. First of all, let's look at problem number 1 in day 1 assignment. This problem says we have 5 pineapples on one plate. Now, we want to put these 5 pineapples into 2 plates, and there are 4 ways to do that. What we need to do is to write out these 4 ways. Obviously, what we can do is we can put 4 pineapples in one plate and 1 in the second plate. So 4 in one plate and 1 in one plate. If we write into addition, this is 4 plus 1 equals 5. Or we can just put 1 pineapple in one plate and 4 in the other. And this is 1 plus 4 equals 5. Or we can do is put 3 pineapples in one plate and 2 pineapples in the other. And this one says is 3 plus 2 equals 5. The last one is 2 pineapples in one plate and 3 pineapples in the other, which is 2 plus 3 equals 5. So these are 4 different ways to put 5 pineapples into 2 plates. Here, we do not include 5 plus 0 or 0 plus 5 because we have 2 plates, and obviously we want each plate to have at least 1 pineapple. Question number 2. This problem says we have 1 cat. Also, we have Olive and little penguins. The first 2 pictures tells us, the first picture says 1 cat equals 2 olives in terms of weight. And the second picture says 1 olive equals 3 little penguins in weight. And what we need to find out is how many little penguins equal to the cat in terms of weight. Okay, if we look at the picture, so 1 cat equals 2 olive. Each olive equals 3 penguins from the second picture. Okay, so each one equals 3 penguins. And therefore, if we combine this together, it's 1, 2, 3, 4, 5, 6. Okay, so what we have is 1 cat equals 6 little penguins in terms of weight. So we can put it right here. So it's 6. 3 plus 6, 3 plus 3 equals 6. Question number 3. This is a problem from Math Kangaroo. The first picture says we have 2 apples. Together, they cost 6 cents. So 2 for 6. Now, if we split 6, because here what we have is 2 identical apples. Therefore, what we have is each apple costs 3 cents. We split 6, 3 plus 3. And then each pear, so here says we have 2 pears. Together, they cost 6 cents, 8 cents. Now we split 8 into 2, so that's 4 plus 4, right? So we say, okay, so then each of them costs 4, so it's 4 plus 4 equals 8. The question asks, if we combine a pear with apple and together, how much do they cost? From the previous 2 pictures, we know 1 pear costs 4 cents and 1 apple costs 3 cents. If we together, 3 plus 4 is 7 cents. So the answer is 7 cents. Question number 4. Here we have 2 numbers, and they are represented by, one is by square and the other one is by a star. Now, what do we know is the square plus star equals 8, and then the star plus 3 equals 6. And we need to figure out what they are. From the second one, we get if star plus 3 equals 6, and then we say, okay, we get star equals 6 minus 3, which is 3. All right, so we figure out the star is 3. And then we can put it right here, or we can replace star just by 3, because you already find out the star represents the number 3. Okay, so then from here we get the square, replace the star by 3 equals 8. Okay, the square plus 3 equals 8. And this tells us the square equals 8 minus 3, which is 5. Okay, then the star is 3 and the square is 5. Day 2, problem number 1. The problem says, here we have 3 adult dogs and 5 baby ducks. They were swimming in a lake. And after a while, 5 of them left and come ashore. So 5 after a while, 5 of them left. They left the lake. The question is, at least how many baby ducks remained in the lake? Okay, among these 5 ducks, some of them might be baby ducks and some of them might be adult ducks. Now, what we want is, we want the baby ducks to remain in the lake, as many as possible. Therefore, what we can do is we say, okay, all these 3 adult ducks left. Okay, so 3. And then there are 2, we need 2 more, right? Okay, so then we have to choose 2 baby ducks to leave as well. Okay, so that's the best we can do in order to keep as many as baby ducks in the lake. Okay, therefore, the answer is 3. Okay, so 3 adult ducks left and plus 2 baby ducks left, so that's 5. And the remaining ducks are 3 baby ducks. So at the most 3. Question number 2. Little Thor assembled a stacking toy as in the picture. How many discs will he see if he looking from above? Now, if we look at this from above, clearly we can see this one. So this is the one that we can see, right? Which is the top one. So I just see from the top. And the second can also be seen because it's longer than the first one. However, so the second can also be seen. However, we are not able to see this because it's covered by the one above it. So here is, let's look at here. So here we have 3 books, right? So if I see this from above, and of course I can see this one, and not this one, because this one is covered by that. Another way to see is we see from, this is the way how we see from the top, right? We can see this, we are able to see the one behind it because it's bigger. However, we are not able to see the one on the back because it is covered by the one above it, which is bigger, right? Okay, so by this, we know we are not able to see this, but we are able to see this. We are not able to see this. Again, it's covered by the one above it because it's larger. All right, so in total, we can see 1, 2, 3, so 3. Okay. Question number 3. Here we have a turtle and a rabbit. Again, we are comparing the weight of a turtle, rabbit, and balls. The first picture tells us 2 turtle plus 1 rabbit equals 10 balls in weight. And 1 rabbit is the same as 4 balls, right? 4 balls. Okay, the question is, if we compare a turtle with the balls, how many balls we need so that the weight is equal to 1 turtle, right? So if you look at the picture, okay, so if we go from here, we say, well, I know a rabbit is the same as 4 balls. So we can move the 4 balls from here, right? We can move 4 balls away. It's the same as 4 balls, or let's draw this way. So it's the same. I can just move 4 balls away, all right? And then this tells us, okay, 2 turtles is the same as 6 balls left, right? 10 balls, 4 balls are removed, then we have 6 balls left. Now, because the 2 turtles, we need to split these 6 balls. right? Okay, so let's split this 6 balls. So we split the 6 balls is 3 plus 3. Okay, so 1 turtle equals 3 balls. So we can put it here. So that's 3 balls for 1 turtle, right? 2 turtle for 6 balls, and then we split is 3 plus 3. So 3 balls for each turtle. Question number 4. Here we have 5 numbers, 1, 2, 3, 4, 5, and we want to put them into here 5 boxes so that the equality hold. What you can do is just put numbers into those boxes and play around, and then you will see there are 2 ways to make it work. One is 3 minus 2, right? So if we put the boxes, so it's minus this equals this minus that equals that, right? So one way we can do is we say, okay, it's 3 minus 2 equals 5 minus 4, or both of them equals 1 and equals 1, right? So this is one way to do. Or we can do is equals that, or we can do is this one equals 3. We can do is 5 minus 2 and 4 minus 1, right? Both of them equals 3. 5 minus 2 is 3, and 4 minus 1 is also 3. So these are 2 ways we can make it work by putting these 5 numbers into these 5 boxes. Day 3, question number 1. Here we have a number of pots and a number of flowers. And the question asks, how many flowers do not have pots? 1 flower is for 1 pot. Now, you see we have 4 pots, right? So that is because 1 flower is for 1 pot. Then what we have is 4 flowers. We can find for each of them, we can find 1 pot. So 4 flowers have pots. And then the remaining 3 flowers do not have pots. So the answer is 3. Question number 2. Here we have 4 mushrooms. And then we also have and also we have 4 Smurfs. And we need to find is what are the numbers we should put on this mushroom and this Smurf. Okay, let's observe the pattern. If I look at the mushrooms, we have 8, 6, and 2. So which number should we put in this mushroom? Well, if we look at the pattern, we think it's from 8 to 6, right? It goes down by 2. And then if I put the number as 4 here, you see we have a nice pattern, 8, 6, 4, and 2. So each time you go down by 2, 8 to 6 go down by 2, 6 to 4 goes down by 2, and 4 to 2 goes down by 2. Okay. Now then, how about the Smurfs? We have 3, 5, and 9. So 3, 5, 9. So what number should I put in the middle so that we have a pattern? Here is similar. 3 to 5, we goes up by 2. So if it goes up by another 2, let's say this one will put a 7 here, right? If I put a 7 here, and then we'll 3 to 5, 5 to 7, and 7 to 9. So each time again, we go up by 2. And that's the pattern we have, right? 3, 5, 7, 9, and 8, 6, 6 to 4, and 4 to 2. Question number 3. The problem says 4 friends A, B, C, D, they are picking flowers. And we know that A didn't pick the most flowers, but he picked more than B and C. B picked less flowers than C did. Based on these 2 pieces of information, we want to rank these 4 people, A, B, C, D, from the larger to the least in terms of the number of flowers they picked. Okay, now let's write them out. We start from the largest and to the least in terms of number of flowers. Okay, we know that B picks less flowers than C did. that means C picks more than B. So we put C in front of B. Right. Here I use this notation means C is more than B. So this notation means more than. So C picks more than B. And also we know that A didn't pick the most flowers, but he picked more than B and C. So A shall be in front of C and B. Now, how about D then? So, okay, we kind of know the positions of A, B, C. How about D? Because we have the A did not pick the most flowers, so A is not the largest. And the B and C, they are less than A, so the largest has to be D. So D pick the most flowers. So D is more than A is more than C, and C is more than B. And this is the correct ranking from largest to the least. Question number 4. The problem says when Benjamin, so let's say we put a Ben. So when Ben was born, Austin is 5 years old. 5 years old. Then when Benjamin celebrates his 5th birthday, so that this is his 5th birthday, that means after 5 years. So he was 5 years old by then, right? After 5 years. And what is the age of Austin? Okay, so Benjamin 5th birthday, so that means after 5 years. Austin, when Benjamin was born, Austin is 5 years old. So add another 5, we get is 10 years old. So Austin was 10 years old when Benjamin celebrates its 5th birthday. Day 4, problem number 1. The problem says Kelvin, Hobby, and Susie each has a number on their cards. If we add the number of Kelvin and Hobby together, let's add together, we get equals 10. And if we add the number of Kelvin and Susie together, the sum is 7. So add together equals 7. Now, based on this, we know the Hobby's number has to be larger than Susie's number, right? Kelvin, okay, so what we have is Kelvin. So this is Kelvin's number. Kelvin's number plus Hobby's number. So this is Kelvin, Hobby's number. We know this is 10. And Kelvin's number plus Susie's number. So this is Susie's number equals 7. Okay, Kelvin's number is the same. But if add Hobby, you get 10, and Susie equals 7. So that means Hobby's number must be larger than Susie's number, right? Then you get, because both of them add to Kelvin's number. The question is, how much larger, right? How many more? Okay, you see, if you want to go from 7 to 10, you have to add 3. So that means if you add 3 more to here, you get a 10, right? You get 10. Okay, then if you compare to this, your Kelvin's number is the same. In order to go from 7 to 10, what you should do is Susie's number plus 3, and 7 plus 3, this gives me 10. Okay, and we conclude Hobby's number is 3 more than Susie's number. Now, if this is not so clear to you, another way you can try is, okay, I just use special numbers. Right? Okay, so what we can do is, let's say I choose Kelvin's number to be 3. Okay, let's say Kelvin's number is 3. Just use an example to demonstrate. Let's say Kelvin is 3. If Kelvin is 3, because Kelvin plus Hobby is 10, then Hobby's number is what? Is 7, because 3 plus 7 is 10. Then how about Susie's number? Well, Susie's number, because Kelvin plus Susie equals 7, so this one will be 4, right? 3, 7, 4. Now, if you look at the difference, it's okay. Now I look at Hobby's number and Susie's number. So 7 equals 4 plus 3, right? Plus 3, okay? So then we just get the same thing. Hobby's number is 3 more than Susie's number. You can try other examples. So it's okay. How about I try the other example? Let's say Kelvin is 5. If Kelvin is 5, then hobby is also 5 because you have added together to be 10. And the Susie's number will just be 2 because Susie plus 7 Kelvin is 2, right? So this is another possible way. And if you compare, it's okay, let me compare Susie and hobby. It's 5, 2. Now 5, 2 is 3 more. So again, we just get is 3 more, right? 3 more. So they're all the same as what we got. Question number 2. Here we have 12 sums, and we want to put them into 3 groups in terms of those that less than 6, equal to 6, and greater than 6. Now less than 6, we can use this notation, means less than 6. This means equal 6, and this is greater than 6. All right, so let's look at which are less than 6. Obviously says 3 plus 0. This is less than 6 because this guy just 3. And then we also have 3 plus 2, which is 5, right, which is less than 6. And 5 plus 0, which is also 5, less than 6. And 2 plus 1, this is 3. That's also less than 6. Right? So that's what we have. Now, how about equal to 6? Well, 4 plus 2, which is 6, right? And then we have 5 plus 1, which is 6. And we have 6 plus 0, which is also 6. Now let's look at those that are greater than 6. Well, 5 plus 2, which is 7. That's, of course, is greater than 6. And what else? Well, 5 plus 3, which is 8, greater than 6. 4 plus 4, which is also 8, greater than 6. And we have 5. Okay, so we also have 3 and 3 equals to 6. Okay, and then we have 5 plus 4, which is 9. That's also greater than 6. All right, so then we put them into 3 groups: less than 6, equal 6, and greater than 6. Question number 3. This is kangaroo math question. Here we have 5 people, say they are participating in computation, and that's how they show on the podium. And usually we know, right? If you look at the games in Olympia, we know usually when those people they go to claim their award in the ceremony, they go to podium. The higher you are on the podium, that means the higher your rank. So here's the runners, right? All right, so then let's see which one finished the 3rd. Because the higher the step, higher the rank. Okay, so this guy is the highest. So he must be the champion, finish the 1st. What's the 2nd highest? Okay, so this guy is 2nd highest. So it's the 2nd, which is the 3rd. And this one is the 3rd. So that's what we are looking for, the 3rd one. And we can keep, this is the 4th, and this is the 5th. Okay, so this guy is the one that finished 3rd. Question number 4. Right here we have a number 2, 4, 1, and then we have one number that is missing. We need to figure out what number this is, right? In order, eventually we come up with number which is 8. Okay, let's do it. So first of all, we see 4 plus 6, 2 plus 4. We can add this one first. So this one equals 6, right? So then we just get, okay, this question mark plus 6 and minus this number 1, this one equals 8, right? Okay, so now we know 6 minus 1, this one is 5, right? We can do this one first. And then we just get this number plus 5 equals to 8. Now, which number plus 5 equals 8? Well, we know it's 3, right? 3 plus 5 equals 8. So we get this number is 3. Day 5. Question number 1. One day, Carlos ate 2 pieces of chocolate. His brother Dave ate 3 more, and his sister Elena ate 1 less. Now, if we combine all the pieces of chocolate eaten by Carlos and his siblings, what's the total number? Let's write out. So Carlos, okay, so let's look at the solution here. So Carlos ate 2 pieces of chocolate. His brother Dave eats 3 more. So 2 plus 3, which is 5, right? So Dave ate 5 pieces of chocolate. And then his sister Elena ate 1 less. So it's 2 minus 1, 1 less is 1. All right. Now what we want to find is the total if you combine them together. So if we combine them together, the total number, which is the sum. So it's 2 plus 5 and plus 1, that's the total, which is 8. So in total, they ate 8 pieces of chocolate. Problem number 2. Leo drove from Irvine to San Francisco along the Highway 5. So Leo drove from Irvine to San Francisco. He left at 9 a.m. in the morning and spent 7 hours on the way. Now, when the question asks, when Leo arrived at San Francisco, what time is it? Okay, now we can start from 9 a.m. and then after 1 hour, you go will be 10 a.m., right? After 1 hour, if you add 1 hour, and then if you add another 1 hour, it will be 11 a.m. So another 1 hour, and you'll keep doing. Then you add 1 more, so 12 p.m. And then you could afternoon is 1 p.m., right? And then you get 2 p.m. and then it will be 3 p.m. Okay, so how many we add? 1, 2, 3, 4, 5, 6 hours. So we need 1 more hour. Okay, so 1 more hour, and it will be 4 p.m. So when Leo arrived at San Francisco, the time is 4 p.m. Okay. All right. Question number 3. Here we have we have this figure, and we want to fold this figure into a cube, and then each face has a number, right? So we want to find out what is the number that is on the opposite of the face 0, right? On the opposite of 0. Now we want to fold along those lines. Okay. Here is what we have here, right? So 0, 1, 3, 4. Okay, now I'm going to fold this. Right? So we fold along those lines and we form a cube. So I fold it, right? So we fold this, go down, and this go here, and this go this. Now, and this gives us a cube, right? We get a cube here. All right, so we have this is 0 on the top. This one is 2. This one 2, and this is 4, right? So it's 1, and this is 3. Okay, now this is 0. Which one is on the opposite? So let's look at the opposite. The opposite is 5. So 5 is the opposite of 0. So this is how we form the cube. We fold it. I fold, goes back, and this gives me a cube. Right. Okay. So the answer is 5. So 5 is on the face that's opposite to 0. Question number 4. Here we have a cat and a bowl of milk that in the opposite corner of the board. Now the cat wants to reach the milk. According to the problem, it can go horizontally or goes down, right? To the right, horizontally goes to the right, or vertically goes down. And the question asks, in how many ways can a cat reach the milk? All right. Okay, so first, the cat can go this, right? So this is one way, reach the milk. Go this and reach the milk. And this is one way. Or the cat can go to here and then goes down and then to this. This is the second way, right? So this is the second way. And or the cat can go is goes to here and then go down to here and then goes to the milk. So this is the third way, right? The third way. Or the cat can go is start from this and goes down first, right? Goes down first, goes down to here, and then all the way to here, and then go to the milk. Right, so this is the first way. Or the cat can go down here, goes to here, and then goes down here and goes down here and goes to the right. This is the fifth way. And there's one way left, which is if we go like this, go all the way down first, and then all the way to the right. And this is the sixth way. So if we combine them together, you see, we can go right, then down, or we can right, down, right, down, right? Okay, so all those kind of combinations. So that's all we can find according to the rule. So in total, the number of ways is 6.